So find the length and width find the length and width of a rectangle. So of a rectangle with maximum area. So with maximum area, And there's a condition. They give us a fixed perimeter. It says that has a perimeter of 9p units. That has a perimeter. I can't spell perimeter. It's perimeter, I believe. Yeah, perimeter. Perimeter of 9p units. So what's p? I have no idea. But the homework does this, so I figured I'll do it like the homework. So find the length and width of a rectangle with maximum area that has a perimeter of 9p units. So basically, you're given a fixed amount of perimeter, and you're trying to find the biggest possible rectangle. So let's go through it. So the question is to find the length and width. So solution. So we're trying to make the rectangle as big as possible. So before we do anything, maybe we should draw a picture of a rectangle. So here is a rectangle. That's a rectangle. And I guess we should give things names. So maybe we can call this x. And so if this is x, this is also x. And maybe we can call this, I don't know, y. So this is y, and this is y. By the way, I'll upload last time's lecture tomorrow. I have it, I just haven't. I just uploaded it this morning. You just finished uploading, so I'll put it up on there.
That says 9p?
Mm-hmm. I know, it's really weird. I have no idea. Yeah, no, I don't know. Yeah, I don't know. It's really bothers me. I should be like, yeah, I don't know why this is Jeff. Yeah, I guess p for perimeter, but why the 9, right? So what do they even do?
Part of the number.
No, it's like 9 times p. P is just like a constant.
Oh.
Mm-hmm.
Sweet.
Yeah, it's weird. It makes it harder, actually. They should have just said like 100. I don't know why they didn't do that. I mean, I could have changed it, but the homework does this. Okay, so we know something about the perimeter. To find the perimeter, what do you do with the lengths? You do what with them? Add them all up. Yeah, good. So we know that 2x plus 2y, that's the total perimeter. But the perimeter is equal to what in this case? 9p. Yeah, 9p. Good. If this was ever on a test, I'd probably give you a number instead, like 100, just to make it a bit easier. It's kind of uncomfortable. Okay, so that's the given information. We're given the perimeters. We've written that down. We drew a picture. We wrote that down. So now, what are we trying to do? Is we're trying to maximize the area. So the goal here is to maximize the area. So let's write the area. The area, if I call it f of x, so it's a pure function of x, it will not be a pure function of x. It'll be something else. Area is length times width. So it would be x times y. So that would be the area. So that's the goal. The goal is to make this function as big as possible. Big as possible. But there's a problem. This is a function of 2 variables. So we can use calculus 3 to do it, but this is calc 1, so we should be able to make it easier. So we want to maximize this, so we have to get rid of the y. So what we can do is we can solve this one for y, and then plug it in here. Okay, so typically that's what you do. You have like some formula, and then you solve for one of the variables, and you plug it into the other one. So to solve this for y, we'll subtract 2x, so minus 2x. Hey, you're back! So we get 2y equals 9p minus 2x. Judah, right? Yeah, Judah. Yeah, it's good. I'll post the lecture tomorrow morning, the one from last time. It was really easy last time. It wasn't, well, I thought it was. Well, except the graph, but it's a piece of cake. Easy problem. We did every single homework problem last time, too. And yeah, it's kind of nice. Divide by 2. Ugh. So y is equal to 9p minus 2x over 2. And then we just plug it in here, which I'll do in a second. So now we take the y, we plug it in here. So we get f of x equals x times y. But y is just this piece here. So it'd be parentheses 9p minus 2x all divided by 2. Any questions so far on anything? Everyone okay with? Just plug it in here. I'll pause. We got time. We got time. I like how it doesn't follow me now. It's so nice. I did it in my other. I can walk over here. Hello. Like it doesn't know what I'm doing. Yeah. It can be. Yeah. I know because we used x and y. I know it's kind of yeah. Yeah, I could have used other letters though, but yeah. Good question, Sarah with an H. I know your name because last time Sarah's method. Yeah, it's good. I'll never forget. It's great. Yeah. Any other questions? Any other questions? I'll wait a moment. So okay. So recap. So the question wants us to find the length and width of a rectangle with maximum area that has a perimeter of 9p units. Hey! Oh, you're already here. Okay. so you have x, x, y, y. And then we know perimeter, that means you add up all of the lengths of the sides. So x plus x is 2x, that's how we got that, and y plus y is 2y. So 2x plus 2y is equal to 9p. I know the 9p is not fun, but it makes it harder. And then we want to make x times y as big as possible, because that's the area. So then you solve this for y. So you subtract 2x, you get 9p minus 2x, and you divide by 2. Then you plug the y in here. So the goal is to maximize this. That's what we have to do. We have to make that as big as possible, right? Because this is the area function. Okay, this is the area. So what you can do now is distribute the x. So f of x, this is actually 9px. I'll show the steps too. Minus 2x squared over 2. I know I'm going to break it up. I was going to break it up all at once, but I felt bad. I figured I'd show you an extra step. We got time. So this is 9px minus 2x squared. And then you can break it up. So it's 9p over 2 times x, because it's 9px over 2. Hey, it's all right. And then this over this, this over this is just going to be x squared. Yep. Yeah, because it's 1. Yeah, 2 over 2 is 1. All right, Ethan, I'll go over it again. Don't worry. Sorry. No, it's okay. It's good. Better late than never, right?
Yeah.
So, yeah. I knew a guy once. He was always late to every single class.
Is he Ethan Bronson?
No, his name was Pere. He was really cool. He was really big. He had dreadlocks. He was huge. It was really funny. Okay, so find the length and width of a rectangle maximum. So we're here. We drew the rectangle. We found the perimeter. We found y. Plugged it in. So we're here. So the goal is to maximize this. So the way to do it is to use something we did last time. Kind of, yeah. We didn't do it last time, but something we've used before. What test can we use to maximize things? Do you remember? Second derivative. Yeah, you weren't even here. Yes, good. So we're going to use the second derivative test. I'm going to write that down. So use the second derivative test. So super key. So it's super important to do it on the test, okay? Please don't forget. The most common mistake on the test is that people will start to use the second derivative test. They'll get the critical number, and that's the answer, and so they'll quit. So go through the whole test. Please go through the whole test. If you don't, you lose some points. Not all of them, but it's like minus 2 or 3. But yeah, so go through the whole test. So to use the second derivative test, you always find the critical numbers first. So you take the derivative, and you set it equal to 0. Good! So we got to differentiate this. So f prime of x this is a constant, this 9p over 2. It's like 3. It's a number. So when you take the derivative of x, I coughed. No, I'm fine. When you take the derivative of x, you get 1. So you get 9p over 2 minus 2x. Well, you were sick, right, AC, a while ago, but that's gone. That was a long time ago. No, sorry. So 9p over 2, derivative of x is 1, and this derivative is here. Okay, and we set it equal to 0. Oh, Ethan, since you weren't here, and some people who walked in a little late, so the school was talking about if something happens with, with the C virus thing. I didn't want to say it. I don't know why. Yeah, it's like I don't know. I don't know. You know what I'm talking about? Everything's going to go online. Like all the classes will become online classes. Yeah. So.
UF is like they've already sent out emails to the students.
Yeah, I can't believe it. Like wow, it might happen here. That'd be interesting. Huh? Yeah. Subtract this.
That's kind of like annoying. Because what if you don't take online classes? That's not how you like learn.
I know. Don't worry, I'll make it really easy. I'll try to make it as easy as possible because you're right. You're right. Plus, what if you get sick or something, right? Like, have to take that into account, right? I mean, what if someone you know is sick?
Why don't we all just pass and not go? Like, what if we just finish the semester with the graveyard hat?
Yeah, I think some people might not like that. Yeah, you see? Yeah, I know. It's a good idea if you're doing good. And then multiply by -1/2. No, I'll try to make it as easy as possible. Don't worry.
Somebody's not trying to make it as easy as possible? I'm kind of nerdy.
No. Wait. I don't know the right answer to that. Awesome. What is this called? We found it. What is this thing? What is it called? Critical number! Yes! It's CN! Oh, it's got the letter C in it. CN! CN, critical number. Critical number. So we found that's actually going to be the answer, okay? That's actually the answer to the question. This is the width. But you're supposed to keep going. You're supposed to like do the second derivative test. So now you're supposed to take the second derivative. So when you take the second derivative, yeah.
So in every problem, the CN is going to be up.
Pretty much. Or you can plug it back in to get the answer, or you'll be done.
So it's just asking for the width, or for the length, then we're done.
Yeah. Okay. Yes, we'll find the length in a minute. Yeah. But for every problem, whenever you get here, you're pretty much done. So the rest of this is just a formality. There's some problems, but they're not in the homework, where you have two critical numbers and one of them doesn't work. But you have none of those in the homework, so that's good for you. This derivative is 0 because it's a constant. What's the derivative of -2x? -2, yeah, -2, this is -2. And this is going to seem ridiculous, but sometimes it's good to be ridiculous. F double prime, now you plug in your CN of 9p over 4. If you plug it in to this second derivative, well, nothing happens. It's just -2. It's less than 0. Yeah, for x, because there's no x. So you just get -2. Yeah, there's no x. So we have, let me write it. So we have a max at x equals 9p over 4. Whoa. 9p over 4. I like to write it down. It's better if you do. It's better for you too, like as a human being, to get into the habit of writing it down and explaining things. Higher level math is like this. You explain everything. Everything's in words. It's like paragraphs. So please don't forget to always do the second derivative test. So this is the answer. This is one of the answers. This is the width. Yes, Jack.
So we have like, can we do it as order pair? So we have the max at like -2, 9p4 -2, or
yeah, you could do it that way also, but it wouldn't be at -2. You'd have to plug the 9p4 back into the original. Yeah. So that's the width. So now we need the I guess this piece here. What is this piece called? No, that's not the width. That's the length, I guess. That's the length, right? This is the width. Length, width. So this is the length. You write that down. I misspoke, but that doesn't count as a mistake, so sorry. Length. So to find the width, we have to take the x and plug it in somewhere. I'm guessing we can just, we can plug it in here, right? So let's plug this back in here. So we have, so plug x equals 9p over 4 into this, y equals 9p minus 2x over 2. So it'd be 9p minus 2, okay? And then your x is 9p over 4. I'm showing like a lot of work. I think because it's weird. The fractions are weird, and I feel like I should show extra steps. So plug that into there. And then this is going to be 9p minus 9p over 2 over 2. If you take 9p and you subtract 9p over 2, you're left with 9p over 2. You say, what? Because if you take a whole 9p and you subtract, it's like you have 9p and you're subtracting half of 9p. So you're left with half of 9p. Does that make sense? It's like if you have x minus 1/2 x, you get 1/2 x. You take a whole 9p, take away a half 9p, you get a half 9p. So you have a half 9p over 2. When you divide by 2, you really multiply by the reciprocal by 1/2. So this is 1/2 times 9p over 2. So this is 9p over 4. So that would be the width. So it's a square. So it's a square. And I almost ruined it at the beginning of the problem because I was going to say it. And I thought, no, let me not say it. And I was like, I struggled really hard to not say it. So if you have a rectangle and you're trying to make it as big as possible, you make it into a square. So if you're wondering how you can use this in the real world, I was thinking like, okay, let's say you have a backyard and you only have like $100 and you go to Lowe's and you want to build like a garden. You say, I want to build the biggest garden I can possibly make. Well, you should make it a square. It's like if you only have 100 feet of fence, the biggest, say you have 100 feet of fence. The biggest garden you could make would be 25, 25, 25, 25. That'd be the biggest you can make. So if it's going to be rectangular. So the biggest rectangle is a square. Cool, right? It's like a life thing you can use. You can tell people. You can show off at parties. You know, like, oh yeah, I'm redesigning. I'm building a garden. I'm like, oh yeah, you should make it a square, and you can like explain it. Pick up lines or not. So, but I'm kidding. Any questions? Any questions on this one? Yeah.
So you said on the test you'd normally just give us like a number. Mm-hmm. So would it just be instead of 9p? 100.
Mm-hmm. If it's on the test, honestly. I mean, I usually don't. I'll be honest. I usually don't test you on this one. Do you want this one on the test or? Yeah, it's not bad. Yeah. Oh, you got a question? No, I thought you had a question. No questions? No questions. Any questions? The next problem is way cooler than this one. I'm not a big fan of this problem. Just the square part's cool, I think, but I don't like the 9p. I just don't like it. I know, right? It's all of that just to subtract. The next problem is really cool. So the next problem is something you'll definitely see. It's on every single test usually. It's on the old exam. So let's do it. But any questions? Any questions? We got time, so. All right. We do one more example and then we'll go to the next section actually. So this next example is a little bit more interesting. And this comes up in Calc 3 also. In my Calc 3 class, they have a bunch of these, but it's in higher dimensions. In this class, we do it in 1 dimension. So the question is to find the point on the graph. There's actually a video for this too in the playlist already. Find the point on the graph that is closest to the given point. So find the point on the graph that is closest to the given point. And so they're going to give us a function, and they're going to give us a point. And we're going to find the closest point on the graph. So it's kind of cool. I like this problem a lot. So f of x equals the square root of x, and the point is 7, 0. I always remember one semester I mixed up the numbers on accident. I had 0, 7. Oh, yeah, it made it really hard, and I pointed out the mistake in class, and the whole class was like, oh, and it was like on the first page, and so everyone was stuck for like 30 minutes. It was just really bad. So that won't happen, don't worry. I don't remember what I did. I didn't do the point thing back then. No. I don't know why I started that. Oh, I know why. See, back then it was worse. I would be doing a problem, 30 minutes later, shouldn't that be a negative sign over there? No! I'm like, have to fix everything. I'm sure you've had that happen. That's not fun. Okay, so what are we supposed to do? Let's draw a picture. So pick. So this is the y-axis. This is the x-axis. I guess I should label them, I guess. Well, I won't. Well, okay, why not? Y, x. And the square root function looks something like this. It's like a little finger. It's like a square root function. And 7 comma 0 is here. So you got to find the point on the graph of this function that is as close as possible to this point. So maybe it's here. I don't know. Maybe it's there. I don't know where it is, but obviously it's not going to be over here because that's far away. It's probably going to be somewhere over here. So I'll draw a line. And let's call this distance here d. So basically we have to make d as small as possible. That's the goal. So this point, every point on a graph is x comma y. So we can write this as x comma y. Hey, oh, you're right. But something that Sarah actually said, Sarah with an H, y is actually f of x. But f of x is the square root of x. So this is actually x square root of x. Yeah, yeah. That's cool that you said that earlier, Sarah. Like it came up, right? It's so good. Yeah, so that's how you do it. Every single time in these problems, you have to use the fact that y equals f of x. So you replace your y with the square root of x. There's a couple in the homework that are a little bit harder, but we can look at them later. This is a good one for the test. So step 1 in this problem, again, I'll do it again from scratch. You draw the picture if you want to. Here's 7, 0. Pick a point and call it x square root of x and call that d. That's the first step. Okay, that'll be a good way to start it. So I don't know if you all remember the distance formula. If you have 2 points, the distance formula, you subtract the x's, you add and you subtract the y's. Remember this? It comes from the theorem of Pythagoras, the Pythagorean theorem. That's called the Euclidean distance, or just the distance. It's a straight line distance. There's other ways of measuring distance in math. This is just like the easiest way.
We have to have this memorized.
Yeah, yeah. So basically, you just subtract the x's. It doesn't matter what, you can put the x2 here, by the way. It doesn't matter. You can mix them all up. As long as these are x's and these are y's, things are good, because everything is squared. So it doesn't really matter. So let's find, so the goal is to minimize d, little d. Oh, I remember this problem. It's coming back now. So it's the square root. There's something tricky about it. And basically you subtract the x's. So you do x minus 7, and then you square that result. So x minus 7, square that result. And then plus, I almost messed up, but I didn't. But I'm not, yeah, y minus 0, but it's not y. What is it? Square root of x. Yeah.
Why is x1 just x?
Oh, because it can be. It doesn't matter. It doesn't matter. You could do 7 minus x.
Oh.
It wouldn't matter. Do you see why it doesn't matter? I'm going to show you. You do? You sure? Because if you check it out, you could be weird. Watch this. Let's be weird. Let's pull out a negative 1, and then you end up squaring the negative 1. And then negative 1 squared is 1. It's really powerful. So it's this. So it doesn't matter which formula. Whenever it's squared. So if you have like 3 minus x, and you don't want to multiply that out, then don't. Just write it as x minus 3. You can do that when it's squared. Really powerful, right? Yeah, it's really, really cool. Same thing with absolute value, right? Absolute value of x minus y is the same thing as absolute value of y minus x. Anyways, any questions up to here? Any other questions? So here's the magical step. I'm going to drop the square root. Say, oh, you squaring both sides? No. Here's the idea. So basically, this will be small whenever what's inside it is small. So the square root is as small as possible whenever what's inside it is as small as possible. You could also think of it like from the graph. The square root of x, the y value is small whenever x is small. It's an increasing function. So this is small whenever the inside is small. So I'm going to let g of x be the inside function. When you square this, you just get x. And we're going to make this small. So again, the goal was to make this small. The square root is small whenever the inside piece is small. So instead we focus on making the inside piece small. I remember when I was taking Calc 1 or Calc 3, and this is in the book, and I remember reading the sentence in the book over and over and over and over. I read it like 10 times and I never understood it. Never understood it. Like, because it's not, I kept thinking like, oh, are they squaring both sides? But it doesn't say that in the book because they're not. Basically, this is small whenever what's inside is small. So instead you just focus on the inside. It's a conceptual trick. It's like a conceptual move. It's tricky. How do we make this small? What do we use? The what? What is it called? It has a name. What do we use to make things small or big? The what test? What's the test we use? Second derivative test. Yes, use the second derivative test. Derivative test. The second derivative test. Yes. So we use the second derivative test. So every time, right? So whenever you get to a step, see, we could have used it here. The reason I didn't use it here is because it has a square root, and that means that we have a really nasty chain rule. But you can just take the derivative of little d, but it's really ugly. So it's better to just drop whatever's inside, drop the square root and focus on what's inside. So we'll take the derivative and set it equal to 0. So g prime of x. So here, when you take the derivative, you put the 2 in the front. So you get 2. Okay, so you get 2. Parentheses, x minus 7. And there's a 1 here. And then in theory, what are you supposed to multiply by in this case? 1. Yeah, that's the chain rule. You don't have to, though, okay? But I'll put it because I feel bad. There it is. It's there. It's good. Plus 1. And this is equal to 0. Everyone okay with this step? It's supposed to be really tricky. Really? Really? Oh, you're going to get an A. Oh, that's so good. 100. Let's rewrite it. G prime of x. 2 times x is 2x. And then this is minus 14. 2 times negative 7 is plus 1. And that's equal to 0. I'm going to write it again. G prime of x. We're doing a lot of extra work. 2x minus 13 equals 0. Showing extra steps. Just make it count. It's an important question. It's something you'll see. Do people sit over here? Like, does anyone sit here? No. So people missing today. Like, I know. Logan's not here today, and then, yeah, I don't know. I don't know if anyone sits there. Does anyone know if anyone sits there? Yeah. Really? Who sits there? Oh, I don't know. Oh, Pistachio Girl. Yes, yes, yes. Neoma. Yeah, yes, yes, yes. Always. And then Lucky's was closing, and I was like, oh, where's she going to get her pistachio? She went to Publix, right? Yeah. Good stuff. All right, so add the 13, divide by 2. That's funny. That's how I remember who it is. That's funny. That's great. Yeah, the Pistachio Girl. And then divide by 2. That's how you remember people, though. It's like certain things. So x equals 13 over 2. What is this? What did we just find? What is this called? CN! Yes, a CN! CN! Corona. This is not corona. A critical number. I was gonna say the corona number. No. It's so bad. I saw the C. I'm like, oh. It's ridiculous. Oh, my God. Oh. So dumb. Now we take the second derivative. So the second derivative. It's 2, right? It's 2. Because the derivative of 2x is 2. The derivative of negative 13 is 0. I like this problem a lot better than the one with the p's. I hate the problem with the p's. I don't like the 9p. This is like pretty and nice. What are we supposed to do next? What do we do next? We plug it in. What'd you say? The OG, no, not yet. No, the OG funk is later. It's going to come back. The OG funk does arise in this problem, Austin. The OG funk, oh yeah. So we get 2. So it's greater than 0. So I'm going to write it. So we have A min, very good. So we have a min at x equals 13 halves. Whenever you get here in the problem, you kind of have to stop and think, okay, you're pretty much done, but you have to go back and think, what did the question even want? Like, what are we even doing? It wants the point. Last time it wanted the length and the width. Here it wants the point. So it wants the ordered pair, the x comma y. So we already have the x. We just need the y. And to find the y value, where do we plug it in? The OG func. Yeah, go back to the OG func. Original, OG means original. Go back to the original function. So I'm going to write that down. Go back. Yeah, go back to the OG func. Go. That's a G. It's a fancy G. Go back to the original OG func. Go back to the OG func. So we get f of 13 halves. So plugging back that into the original function, it's going to give us the square root of 13 halves. But that we're not done, because it wants a point. It wants the x and the y. So the final answer is x comma y. So it'd be 13 halves comma square root 13 halves. Oh, Selena's not here either. That's who else sits there. Yep.
No, she doesn't sit there. She sits.
Really? No. What? You're messing with me. No, Selena sits there, right? Are there two Selenas? There's two Selenas. Yeah, Selena from there. Yeah, from that side of the room. She was in my class before, my pre-calc class. Yeah.
So that,
Yep.
that's the point that's closest to 7, 0.
Yes. So this is the point on the graph that's as close as possible to 7, 0. Yeah, good. Yep. That's it. Any questions on this one? Yeah, there's two Selenas in this class, the one over there and the one over there. Yeah, I guess you don't go to that side of the room often, so.
No, I'm just laughing about that pistachio girl.
Oh, pistachio girl, yeah. Any questions? Any questions on this one? Yeah.
So in the very beginning, you just pick a random point, draw a line, call it D.
Yeah. And then you call this x, call this the square root of x, and then find d, drop the square root, and then, so let's go over it again. So at the very beginning, I'll do it again. Check it out, why not? We got time. So you draw the graph. Here's your point, 7, 0. Pick a random point, call it x comma y, but we know, like Sarah said, it's really x squared of x. Sarah didn't say it, but she said it earlier. So sorry, Sarah. And then this is d. To find little d, you subtract the x's, square it, subtract the y's, square it. So he had asked about, Aaron had asked about how do you know which one's which? It's x minus 7. Or you can also do 7 minus x. You just subtract the x's, square it, subtract these, square it. And then you want to make this small. This will be small whenever what's inside the square root is small, so you can just drop the square root. Then you use the second derivative test on this. So take the derivative, set it equal to 0, find your critical number, and then you just use the second derivative test. So you plug this into your second derivative. It's a lot of steps. It is a lot of steps, but it's not hard.
Yeah, I did.
Yeah. Does that make sense?
So would g of x be the, I guess we don't even really know the distance then, do we?
No, we never found the distance. If you wanted to find what would be the minimum distance?
We have to.
No, you don't. But you know what you would do is you would take the 13 halves and you plug it back into D. And that would give you the minimum distance. Yeah, good question, yeah.
So what you have in the circle is the answer?
Yeah, I should put that down. I should put answer. Answer, yeah, because there's so much stuff on the board. Yep.
So basically, we're using some part of the distance formula, or we're not?
But we're not, yeah. So we use the distance formula to set it up, and then we just focus on the inside.
So we just basically we say screw the square root.
Yeah. Do you know why though?
It's already small.
Kind of, yeah, pretty good, yeah. So this will be small whenever what's inside is small.